In this video, we are going to solve the review problem set 5 that I have given you the last week. So this is the question number 1. You want to make a box with no lid from a rectangular sheet of cardboard that is 18 inches and 24 inches. The box is to be made by cutting a square of side X from each corner of the sheet and folding up the sides. We need to find first the value of X that maximize the volume of the box, and B, the volume of the box. Okay, so let us just draw first a rectangular sheet, and this sheet, out from this sheet we will be cutting a X or box with measurement X from each sides. For example, like this one. Let us just copy this one. Okay, sorry. Let us just copy this one. Hold on. So we will be cutting a square from each corners, like this one. Okay, we're cutting through a square having dimensions of x, no, xx. So lahat ng sides niyan x, such that yung nakat natin will take that out, then yung natira will fold. Okay, will fold from here. We'll fold it through this line. Let me just draw this one. Okay, hold on. Okay, like this one. No, we'll we'll fold it along this line. Okay, and then the box is said to have no lid, meaning to say it is open. It is open on the top. Okay, it's open on the top. Yeah, let me just draw this one for a while. Let me just draw this quick. Okay, this serves as our base. No, this serves as our base, and this one we fold it. Okay, like this one we fold that one, then this one also, this one, and so on and so forth. This 4 sides. No, and then what we expect is we will be able to create a box like this. Okay, having no lid on the top. Okay, like this one. Okay, so that would be our box, no, and this one is X, this one we don't know yet, so let us just call this Y. Okay, and then this one, let us just call this one A, this one is B. So the volume of the lid will be equivalent of the volume of the rectangle, the box now. Okay, the volume of the box would be equivalent to A times B times X, or that is the length times width times the height. No, so we need to find the value of X that will maximize the volume. Okay, it says here that initially we have a rectangular sheet of 18 inches by 24 inches. So let's say, for example, from this corner right here to this corner right here, that is said to be 24 feet. Okay, let us just say that is 24 feet. And from this corner right here, okay, to this corner right here, let us just say this is 18 feet. Okay, so hold on. Okay. Yan. So this one, let us just call that 18 feet. And then since we cut through, okay, we cut a square box on each corner. So this length here would now be equivalent to the remaining length upon cutting through x sides will be now equal to 18 minus x. Since dalawang x yan, so may 18 minus 2x. And then this length here, again like this one will now be equivalent to 24 minus 2x. Okay? And then therefore we can say that a would be equivalent to, let's say for example, this is a right here, this one. Let's say for example that is our a, and this right here will now be our b. Okay, this one right here is our b, so a. So a now will be equivalent to, okay, the volume of the box would be a b x, and a now will be equivalent to 24 minus 2x. Okay, and b will now be equivalent to 18 minus 2x, and to be multiplied by x. So we now have the equation of the volume that we want to maximize. So volume will be equivalent to, let's just do a quick distribution. Okay, 24 times 18, that would be equivalent to, let me just carry out this one using my calculator, 242, 432, and that is x. Okay, now this one also, 18 times 2x, this one. Okay, let us just leave x for a while. So yeah, this one, and this one. Let's just do FOIL. Okay, so that is 243, that's correct. 18 now to be multiplied by negative 2, that would become negative 36x. And then ito 24 times negative 2x, that would become negative 48x. Negative 2x times negative 2x, that would become positive 4x squared. Okay, and then we still have x here, so let's distribute x. That would give us 432x. This one, 36x minus 48x. Okay, that would be added now, since they have the same sign. So that is negative 84x squared plus 4x cubed. So we now have the equation of the volume, okay, that we want to maximize. Let me just check this for a while. Is that correct? 810 times 2, this is 32 plus 48, that would give us 84. That's correct. Okay, so we can now proceed to taking the derivative of our volume with respect to x, and that would give us 342 minus 84 times 2, that would give us 168 x plus this one, 4 times 3, we have 12 x squared. Okay, let me just check. 84 times 2, okay, that is 168. And then we will be equating this to 0 since we want to maximize the volume. Okay, what we need to find is the value of x. So we have here 12x squared. Let me just rearrange this one. 12x squared minus 168x plus 432. Equate that to 0. So we can use the quadratic rule for that now. Negative v positive negative square root of b squared minus 4ac all over 2a. Okay, all over 2a. Okay, so hold on. Okay, so let us just substitute negative, since yung b natin would be negative 168, that is negative 168 positive negative square root of, okay, square root of Let us just see 168 square minus 4. Then we have A, which is 12. Then C would be positive 432. Okay? Okay, yan. And then we have in our denominator 2 times 12. Okay, let's just take out our calculator. Let us check now. So that would be given, that would be negative times negative, that would be 168 positive, plus, let us just start with the positive. So 168 to be square, so that is positive also. Negative 4 times 12 times, okay, 432 all over 2 times 12. Okay, if that is positive, that would give us 10.60, 10.6. Okay, 10.61. And then if that is negative, so this is positive, so if that is negative, and that would give us ito. If this is negative, this would give us 3.39. 3.39. And the unit is in inches. Okay, sorry, this is inches pala, no? So that is not feet, inches pala ito. Okay, anyway, yung dimensions lang yung naiba dito. So let us check. Since there are two possible values for this one, which among these two values is the most possible or most plausible value of x? No. For me, no. Yung 10 is, that is absorbed, that is impossible. Kasi as you can see, that is very close to the length of one side. And then itong 3.39, this is the most possible values of x. But we can actually verify this one if we will plugging in these two values that we just calculated to the volume formula, no? Ito yung volume na formula natin. Now if we will be plugging in x value in here, and then we will be able to get the volume, the magnitude of the volume, and then we will just be comparing which one of these x values will give us a maximum or larger value for volume. Okay, so let us just check. Let me just put it here. 18 minus 2x. Okay, then we have 24 minus 2x, and that is to be multiplied by x. Okay, now let us just say our x value is 10.61, and that would give us a negative, okay, that would give us a negative volume, which is obviously not a maximum. And then if we will be using 3.39 for our x value, so that would give us calc 3.39 a magnitude of 654.98 inch cube. So obviously this one is maximum, is the larger value compared to this negative one. So therefore we can say that this value is the maximum value for our volume, and that would be possible if our x would be equivalent to 3.39. I hope that you were able to get that logic. Okay, so that is the answer for problem number 1. The x value would be 3.39 and the maximum volume will be 654.98 inch cube. Now let's proceed to question number 2. Okay, question number 2. Find the equations of the tangent and the normal lines to x squared plus 3xy plus y squared equivalent to 5 at the point 1, 1. Okay? So, recall natin, tangent line, okay, a tangent line has the same slope to this curve, no? at this specific point. And remember, the slope, or denoted as m, is the first derivative of our function with respect to x, or that is dy over dx. So we just need to find dy over dx here and evaluate it at this point, and then we'll be able to get the slope. And we'll be using that slope to find the equation of the tangent and the normal lines. So normal lines, let's say for example, the slope of the normal line is the negative of the slope, the negative reciprocal of the slope of the tangent line, if you have remember. So let me just put it here. That would represent the normal slope, and this one is the tangent slope. Okay, so therefore we need just to find the first derivative of the given curve. Okay, let me just rewrite it. Okay, so obviously we have here a term that is a product of the x and the y. So in here we will be using implicit differentiation to take the derivative, to take the derivative of each term with respect to x, and that would give us yung derivative ng x square will be 2x dx over dx, or obviously 1, plus this one we can use the product rule. So dx over dx, so let me just rewrite dx over dx here, plus 3, then that is to be multiplied by dx over dx y plus x dy over dx. Then we have here 2y dy over dx equivalent to 0, since the derivative of a constant is 0. Now we will just be plugging in the values, but this dx over dx will be equivalent to 1, also this one. So plugging in values for x and y, since x and y, that is 1 comma 1, that is the point that we are trying to evaluate. So this is 2 times 1 plus 3 times 1 plus 1. Let us say dy over dx is the slope. Yan. So we can just say 1m, or simply m, plus 2 times 1, then m, equivalent to 0. Okay, so we have here 2 plus distribute, that would be 3 plus 3m plus 2m equivalent to 0. So this one adds up to 5, this one is also adds up to 5, equivalent to 0. Transpose this to other side, 5m would be equivalent to negative 5, and dividing both sides by 5, then we will be getting negative 1. Okay, so our slope will be negative 1. So that is the same slope for the tangent line. So therefore the slope of the tangent line would be negative 1, and the slope of the normal line would be equivalent to the negative reciprocal of this value, which is obviously equivalent to positive 1. And now we'll just be getting the tangent line. Okay, for the tangent line we have here y minus 1, since our point is 1 comma 1, then that is to be multiplied by negative 1 as the slope. Remember y minus y sub 1 equivalent to slope to be multiplied by x minus x sub 1. Okay, so we'll be using this one, y minus 1 equivalent to negative 1 x minus 1. So y minus 1 equivalent to negative x, and this is positive 1. Okay, y transpose to other side, that will become negative x plus 2. So this is our equation of the tangent line. For the equation of the normal line, we have here y minus 1 and equivalent to the slope of the normal line, which is equivalent to 1 x minus 1. Then we have here y minus 1 equivalent to x minus 1. Transpose this to other side, then we have y equivalent to simply x. Okay, so that is our answer for the tangent and normal line equation. For our next problem, we have here find the derivative with respect to x of the given function e raised to the power of e which is raised to the power of x, to be multiplied by the ln of tan hyperbolic 2x. Then simplify. Okay, so it appears to be complex function, but that will be easy. Okay, this will be the technique to solving this one will be very easy. Okay, we have here e to be raised by the power of e, then to the power of x, then ln of tan hyperbolic 2x. So we can use the product rule. So the y prime will be equivalent to, okay, we can set this one as our u and this one our v. Okay, so that will become du. So the derivative of e raised to the power of e raised to the power of x, and then copy ln of, okay, we take the derivative of that, and then this one we'll just copy, no? ln of 2x. Okay, this is basically our du. Okay, du times v plus, okay, plus, okay, u dv. That will be our product rule, if you have remember. Okay, and so this one will be, let me just put it here for a while. Okay, so plus, copy natin t raised to the power of x, then derivative of ln of tan hyperbolic 2x. Okay, that's it. So now let us just take the derivative of e raised to the power of ex. So that is e raised to the power of ex, and derivative of this u will be equivalent to e raised to the power of x. Then let's copy ln tan hyperbolic 2x plus this one, e raised to the power of e to be powered by x, and the derivative of ln tan hyperbolic 2x, so yung ln of tan, so that is 1 over tan 2x, and the derivative of tan 2x would be equivalent to secant square 2x, and derivative of 2x would be 2. Okay, we are using the chain rule. Okay, we have y prime, this one to be multiplied. Okay, since yung e raised to the power of x is common, we can factor that out. So we are left with ex ln of tan hyperbolic 2x plus this one will be 2 secant squared 2x all over tan hyperbolic 2x. So that's it. Now we can still simplify this one. E raised to the power of ex. Okay, we can still simplify this one by simplifying this part right here. So let me just isolate this one. Let us just put it here. So I just want you to see how to simplify this one. Okay, since yung secant squared 2x is the same thing as 1 over cosine hyperbolic 2x, and then yung tangent hyperbolic is the same thing as sine hyperbolic 2x all over cosine hyperbolic 2x. So we can just say this one will be cancelled, so that would remain 1 cosine hyperbolic 2x. So therefore we have here 2 over sine hyperbolic 2x cosine hyperbolic 2x. Now, okay, if you have remember this one, this is just a double angle identity. So that would become 2. Okay. Okay, since if we will be multiplying 2 here, okay, if we can multiply 2 here, then we can multiply 2 here, no? So that will become 4 over 2 sine hyperbolic 2x cosine hyperbolic 2x. So this part right here is the double identity, so that will be 4. Then we have here sine hyperbolic 2 times 2x, 2 times 2x, and that would become 4 over sine hyperbolic 4 of x. So this is now the simplified version. Okay, so going back to this equation, So now our simplified version will now be equivalent to e raised to the power of e raised to the power of x, and then that is to be multiplied by ex ln of tan hyperbolic 2x plus this one will now be equivalent to 4 sine hyperbolic 4x. Okay, so basically this is now our answer for this problem. Okay, let me just put a box. Okay, so that is how we are going to answer this problem. Now for our last problem of this day. Okay, last problem for the day. So this one will be very quick. Find the value of x for which the given function is discontinuous. If you have remembered our discussion on continuous and discontinuous function, discontinuous function, okay, discontinuous functions are functions that are discontinuous at a certain point. So how can we find the value of x or the possible value of domains that will make our function discontinuous? So to find the value of x that will make our function discontinuous, we need just to equate the denominator to 0. We just need to equate the denominator to 0, and that would give us this one, 3x, 3 raised to the power of x minus 81, then equate that to 0. We can transpose this one, 3 raised to the power of x equivalent to 81. And we know that 81 can be acquired if we will be multiplying 3 4 times. Is that correct? So this is 3 times 3 times 3 times 3. So this one is 9. 9 times 3, that would be 27. 27 times 3, that would be 81. So we can get 81 by multiplying 3 4 times. So now, using the law of the rule for index law, if we have the same base, that their exponent should be equivalent. So therefore, the x value will be equivalent to 4. That will make this function discontinuous. So that's it for this video. Thank you for watching, and I'll see you in the next one.